Welcome back to our channel, JF Green Energy Concept. This is actually an experiment we conducted, and we want to introduce it to our followers on how to generate more power from your solar panels. Here in Africa, we believe one of the challenges we are facing is the efficiency effect, or will I say the deficiency of most of the solar panels we are having here. And since we have been facing this challenge together, it's been a course that we must undertake to actually give people more benefit for their investment in terms of solar energy generation. Here we are talking about a negative resistance effect on solar power generator. How do you generate free energy from the negative resistance effect? This diagram, you have your solar panels, this is your charge controller, and this is where the whole thing lies. This is the heart of this system. Here you have your solar panels. Here, since you need a charge controller, an effective and efficient charge controller, I want to introduce to you the charge controller we used in our own experiment here, Yohako MPPT solar charge controller. This charge controller happens to be one of the best in our experiment. So this is a charge controller. Then you also need 48 volts voltage battery source. Then you also need 24 volts battery bank. Now we have to consider the energy difference between this and this other in order to determine the inverter you are going to use. Now watch, this is the output of your solar going to your charge controller. From the charge controller, the negative goes to the negative of the first battery bank A. Then the positive goes to the battery bank A positive. Now effectively this is charging this battery from your solar panel. Then when you want to consume this energy, instead of running it the conventional way, which is connecting the positive of the battery of the inverter to the battery, positive and negative of the inverter to the negative terminal of this battery. Now watch, we have two relays. That are involved in this. The common, normally close, common, normally close, normally open, normally open. Now watch what is happening. Positive terminal of your inverter goes to the common. The negative terminal goes to the common. Now from this diagram you can see that the negative terminals of the two batteries are joined together even to the charge controller. Now from this diagram you can observe that when you want to switch on the inverter, the normally close of this first relay is connected to the positive. The second one, the normally close of this second relay is connected to the positive of the second battery bank, which is the 24 volts battery source. Now the normally open of the first relay is connected to the normally close, which goes to the positive. Now this goes, what happened here is that at first this one gets a charge from 48 volt source to the inverter, then negative, everything happens here. You generate your energy, the electrons make their way back to the ground. Instead of passing through the conventional way, it enters the common to the normally closed down to positive terminal of this 24 volts battery before going the ground. This process, this battery is charged through the energy that is consumed by the inverter, and this is more of a chemical reaction that happens in the battery. You are collecting the normal energy, while the chemical effect of that energy you are consuming is charging another battery bank. Now, when this battery is drained, the 48 volt source is drained, and meanwhile the 24 volts source is fully charged, you press a button switching this relay from normally closed to normally open. Now at that point, this relay is now being triggered. It is energized. This common is now connected to the normally open, which this is your positive terminal of the relay. Going here, it is now to the positive of the reactive charge converter, which is the second battery. And the second relay, what happens there is the negative terminal. As soon as the relays are energized, this man moves to the normally open. And as it moves to the normally open, it is connected to the negative side of the second battery, and this relay and this inverter is also working. Now you've now increased the efficiency of this system, or the coefficiency of this system. You are now doubling the power you are using. Now at this point, you are consuming the energy here. This man, if it is in the daytime, this battery is still charging through this solar panel, while you are consuming the energy as a result of the chemical reaction that is happening in the battery. Now as soon as this man is drained, you can now go back to the first one, which is disconnecting the triggering relays and allowing you now, the inverter, to automatically consume the energy from this. While you are consuming this energy, the second battery is being charged. This whole setup, we believe, will open up so many things, whereby if your inverter cannot serve efficiently in this purpose, because you need an inverter with a wider voltage range that can tolerate a wider voltage, because the voltage difference between these should be around from 20 to 24 volts. And also, as this battery goes up charging, most times you can get a charge of up to 28 volts or thereabouts. So most times you can replace this inverter with a motor generator, because DC motors have a wider voltage tolerance, and thereby you can control the speed using a speed control system. This concept can be introduced into our EV motor system that we are using, so that when your battery is down, you are not stranded due to where you are looking for a charge station, because inside your car you now have a backup that is created as a result of the energy you are using. I believe the next one will do more elaboration on this, and meanwhile give us the practical version of what we are doing. Keep believing, keep trusting. We are JF Green Energy Concept. We are here with you in this struggle to liberate our generation from the energy poverty we are faced in this era. Thank you for watching, as we look forward to seeing you in our next video.